In this module, we're going to talk about data wrangling, which is a process of cleaning and joining and, in general, getting your data ready so that you can do some analysis. And we're going to start by talking about joins. In other words, how you merge two different data sets so that you can do some analysis on the two as a whole. So we're going to look how to parse or read in different data sets, introduce the different types of joins, and then we'll walk through this in pandas. Now, we've done some of this data wrangling already. For example, when we're reading in and parsing Craigslist posts, or when we're converting from strings to numeric formats. And so we're going to deepen these skills. And if you think, well, why are we spending time on this? This isn't exactly what I signed up for in data science. Well, sure, it's not the most glamorous part of data science, but in practice, it's going to take up 80% or often more of your time in a real-world analysis project. Because data in the real world doesn't come in a nice, clean format. A lot of your time is going to be spent cleaning it up and merging it and generally wrangling it. So let's start with joins. Before you do any code, you need to step back and think, what's the end result? So for example, in this image, do you want to keep all the observations from this dataset A, even if they don't match to anything in this right-hand dataset B? So this would be called a left join. This is the left dataset, and we're going to keep all the observations from here, and then sometimes we're going to pair them with an observation from the right-hand dataset, but sometimes this area here, they're just going to be null values when there's nothing in B. And these ones here that are in B that not are in A, we're just going to throw these away. Sometimes we want to keep every observation, even if they're only in A or only in B, or whether they're in both. This is an outer join. And then an inner join is only keeping the observations that are in both data sets. Another related question is, do you want to allow more than one match? So for example, if you have a data set of rental properties and a data set of tenants, there may be more than one tenant per property. That will be a one-to-many match. You can also have many-to-one or many-to-many, and these aren't pictured. So this is abstract, but the intuition will become more clear as we walk through specific examples. Now, sometimes a data provider is going to give you lots of different tables that they're going to be very helpful, and they're going to be explicit about how they are joined to each other. And this is a really good place to be. A good example is the California Injury Mapping, Transportation Injury Mapping System dataset, or SWIDRS. This is very well documented, it's very well maintained, and hopefully they give you a nice image of how these datasets join together. So we have a crash dataset here, we have a party dataset here, and it's telling you that these join together on a column case ID, and that it's going to be a one-to-n, or a one-to-many join. So in other words, you can have one crash, but it can involve many parties, perhaps a cyclist and a pedestrian, a car and a pedestrian, and so on. And then you can also have victims. So parties might be the vehicles involved, and victims are the individual people. And so this is also a one-to-n join. So you can have many victims in a single car. And this is joined with two columns, case ID and parnum. So this is a great example of a very well documented dataset where we know how we're going to do the joins. I downloaded 1 month of data to your GitHub repository to save you from registering, and this is from Ventura County. And as always, this code is in your GitHub repository, and don't just watch this video. Follow along actively. Pause at various places and experiment. Why did I use a particular argument for a function? Well, take it away and see what happens. The more you can watch these videos in an active mode rather than just lying back on the sofa and watching, the more useful they'll be. So we'll read all these three data frames using the PD read CSV function. Remember the two dots go up a directory, and then we go down into our data directory, and this is a file name. And you can see how this looks in your folder on your computer. Now, the easiest way to join two data frames in pandas is through setting the index. And we've used indices implicitly so far, but let's look at them in more detail. So all these data frames, these three ones that we loaded in, have an integer index. So we're just printing out what the index is here, and pandas is telling us it's a range index. In other words, an incremental number that starts at 0 and goes through, there's 320 values, so it stops at 319, and our step is 1 each time. So this means that two different ways of accessing that index, so .iloc, which is the position of a row number, and loc, which is the actual index value, these are going to produce identical results. Because of first row or row 0, the index name is also 0. That's not always going to be the case. So if we print using loc, and this is returning the row of the pandas data frame that has the index value of 0. Now iloc, it's going to take just the first row, regardless of what the index is. And here they're completely identical. Now they're not going to be identical if we set the index to a different column. And we can set the index to any column we want, or even multiple columns. So for example, let's set the index here to case ID. And then the in-place keyword is telling pandas we just want to modify collision data frame rather than returning a copy. This is exactly the same as collision data frame without the in-place keyword. So those two things do exactly the same. Try it for yourself and see if that works. So here I'm setting the index of collision data frame and party data frame to case ID. So now you can see, rather than integer index, case ID has been moved from a column up here, like accident year, to the index column. And you can also confirm that explicitly. Let's print the index, we get all these case ID numbers. So now, because we've changed the index, our two methods of accessing a row are no longer going to return the same thing. In fact, if we try and ask for the row that has the index of 0, we get an error message, because that row with index 0 doesn't exist. Now that row has index 8167180. And so we get a helpful error message that we have a key error. In other words, that key is not found in the index. 0 is not in the index. But iloc still works because this is still the first row. So I want you to pause the video and think, how are you going to access this row now using .loc rather than .iloc? And the case number is going to be important here. So hopefully you figured out, well, the case number is here. This is actually the index for this row. This is the same as what we had up here, the first row. And so we can just pass this index number to .loc. And we'll get exactly the same result. So that's a quick tour through indices. Now let's use indices to do the join. There's several ways to do joins in pandas. You can use merge. Personally, I find join to be the easiest in most situations. Remember, if we go back to the dataset documentation, it told us that we should join these two tables based on case ID, which is why we set them as the index. You can join on any column, but joining on the index is usually faster and easier. Okay, so we get an error message. We're trying to join collision data frame to party data frame. What's going on here? What's our error message? Usually read error messages from the bottom. Okay, this is actually quite helpful. It says we have columns overlap, but no suffix specified. And it's telling us what this overlapping column is, accident year. Well, this is telling us that we have a column, accident year, which is present in both our collision data frame and our party data frame. So Pandas doesn't know what to do. It doesn't know which one to keep. So one way to do is to drop them. So rather than join to party data frame, we're going to join to party data frame that has dropped the accident year column. And then we get our join data frame with columns from collisions and columns from parties, which are here, for example, the vehicle year and the vehicle make. Another way to do this is through keeping both accident year columns and distinguishing one of them with a suffix. So using the R suffix argument. So this is telling Pandas that, hey, if any columns in both collision data frame and party data frame are the same, then add this suffix to the ones in the right data frame, in other words, party data frame. So let's join this, and so we see we have accident year here. We also have accident year from party. So my guess is these are going to be the same. And let's see, collision data frame, accident year, is it the same as, join data frame, accident year, is it the same as join data frame, accident year from party? And it looks like it's true for most of these, and we can confirm that using the nice numpy function, numpy all. So basically, are all these values true? And it seems that all of these values are true. So one good practice when joining is to look at the number of rows. In other words, the length of the data frame, both before you join and after you join. And this is really important when you want a data set of unique observations. For example, if you have a data set of census tracts and you only want one row for every census tract in your data. So here, if we're just going to print the length of each data frame, you can see that we start off with 320 in collisions, then we have 632 parties, and then our join data frame has 632. So we did a one-to-many, a one-to-n, so that makes sense. We keep all of these collisions, but some of these collisions join to more than one party. A left join is actually the Pandas default, and you can verify this in the Pandas documentation. So it tells you how you can do a left, right, outer, or inner, or the default is left. Another useful way to troubleshoot joins is unique. And this tells us if a column or an index has unique values. So our original collision data frame, the index is unique. There's one case ID. Each row has a different case ID. But that's actually not true for our join data frame. Why? Because case IDs have multiple parties in some cases. And we can see why if we look at a single case. Let's look at 8167180. And we access this by the index. So in collision data frame, we have a single row. If we want to make this a little easier to see, we can use a range. Essentially, this forces Pandas to report it as a data frame rather than a series, which is a single column and is transposed. But just the range here can help just with the formatting of the output. So now let's look at the same index in our party data frame. Well, we have two rows with the same case ID. And in our join data frame, we're going to have we're also going to have two rows. And for everything that was taken from our collisions, these are going to be identical. The same collision time, the same date, and so on, the same officer ID. But then the parties are going to be different. For example, the race and whether the vehicle was towed and so on. So the columns that are joined from collision data frame are identical. Those from party data frames are not. So why did we do all this? What was the point? Well, now we can do some analyses that need us to combine data from both the collision and the party data sets. We could do the same for the victims data set, which we didn't use here. And that analysis is going to be the topic of the next lecture. So the key takeaways I want to leave you with Sometimes this is a trial and error process, right? You need to look at your data frames before and after the join. See, did I get the number of rows that I was expecting? Look at the index. That's often going to be the key to any joining troubles. And look at your output. If you have fewer rows when you started with, maybe you did an inner join when you didn't want to. If you have more rows than you started with, as was in this case, maybe you did a one-to-many join. So always look and verify to make sure the results of what you were expecting.